Hello friends, welcome back to another video. Today we are going to solve a very interesting problem related to the New Zealand Math Olympiad. Let's see what we have. Find the non-negative integers solution for xpn and p is a prime number. And the equation is 2x times x plus 5 e to the power n plus 3 times x minus 1. Before start the solution, we need to understand certain things about the equation. What is that? We know in general that if the number of variables is equals to the number of equation, then we can easily solve that system of equation. But in our case, we can see that we have three variables, that's x, p, n, but we have only one equation. Okay, so to solve this type of equation, we have to use very different kind of techniques, and today I will show you. So let's start the session. Before start the session, please subscribe, like, share and comment. First, we are going to rearrange the equation. What is our equation? Equation is 2x x plus 5 is equal to p to the power n plus 3 times x minus 1. So we are rearranging the equation. So p to the power n is equal to, we can write 2x times x plus 5 minus 3 times x minus 1, which can be written as 2x square plus 7 times x plus 3, and if we do the factor, then it will come 2x plus 1 and x plus 3. So we have p to the power n can be written as 2x plus 1 and x plus 3. From the equation we have that x, n and p greater than equals to 0, which implies that a factor 2x plus 1 is also greater than equals to 0, and similarly x plus 3 is also greater than equals to 0. Okay, so from here we can say that all the factors are positive, but in the left side we have p to the power n. That means some power of prime p. So from this assumption we can say that the factor of p to the power n, it will be some power of p if they are positive. Also if they will be negative, then we cannot say that, but it will be some power of p. So that means 2x plus 1 is equal to p to the power a for some a, and x plus 3 is equal to p to the power b. Okay, so what is our next plan? Next plan is that what will be our common factor of 2x plus 1 and x plus 3. In order to find this, we need to understand what do you mean by GCD. Okay, so let's see. So first we are going to definition of GCD. GCD, if GCD of a and b, two real number suppose, is equal to k, that means if and only if there exist two integers, okay, two integers, say k1 and k2, such that a into k1 b in times k2 is equal to k. So let's see, we're going to use lemma 1 related to the GCD. If GCD of A and V equal to K, then GCD of B 2B minus A comma B is always K. So let's give an example to understand this. GCD of 4 comma 10 is equal to 2. Then GCD of what 10, 2 times 10 means 20 minus 4 comma 10. It is equal to GCD of 16 comma 10. What will come? This is also 2. Okay. So now we are going to use this lemma to our problem. Okay. GCD we have 2x plus 1 comma x plus 3. So by using the lemma 1 we can write this should be equal to 2 times x plus 3 minus 2x minus 1 comma x plus 3, which gives us GCD of 2x 6. 2x 2 will be cancelled out, that it will come 5 time comma x plus. The GCD will be 1 or 5. If x plus 3 is other than 5, any number other than 5, then they will be co-prime. For that reason, the GCD will be 5. GCD will be 1. And if x plus 3 is a multiple of 5, means, but we know that x plus 3 is nothing but the power of some prime p. So in that case, it can be 5. Like if GCD, like if the number x plus 3 equal to some power of 5, then we can say GCD will be 5. For all such circumstances, the GCD should be 1 or 5. Okay. So now case 1. If GCD of 2x plus 1 times x plus 3 is equal to 5. Okay. Then what will happen? Now we are writing, now we are rewriting the equation again, that is 2x plus 1 equal to some p to the power a and x plus 3 some p to the power p. So this is the greatest common divisor, and we know that the greatest common divisor will also be a common divisor. So that means this 5 also divides p to the power a. So 5 divides p to the power a and 5 divides also p to the power b. So from here we can say that p is nothing but 5. So we get our prime p. Now we are going to use another proposition or another lemma. What is this lemma 2? Lemma 2 is that GCD of a comma b is equal to k, then GCD of a by k, b by k always 1. That means they are co-prime. Let's see example. Example is that suppose GCD of 2 comma 6 is equal to what will be 2. Then GCD of 2 by 2 comma 6 by 2 is what will come? It will 1. Yes, because it's 1 comma 3. Okay. So again we have GCD of 2x plus 1 comma x plus 3 is equal to 5. From here we can write GCD of, we know 2x plus 1 is p to the power a, that means 5 times a, comma 5 times b is equal to 5. By using the lemma 2, we can write 5 times a by 5, comma 5 times b by 5 is equal to 1. So that means 5 to the power a minus 1, comma 5 to the power b minus 1 are co-prime, which gives us, if they are co-prime, what does that mean? The common divisor will be 1. Okay. So, could you tell me what will be a and b? So that means either, because both are the power of 5 and they are co-prime, so that means either 5 to the power a minus 1 equal to 1 or 5 to the power b minus 1 equal to 1. So from here we can say 5 to the power a minus 1 equal to 5 to the power 0, and which we can get a equal to 1. Similarly, here we also get b equal to 1. So we are getting two choices. Okay. So for a equal to 1, what we are getting? We know that 2x plus 1 is equal to 5 to the power 1, means 5, which gives us 2x is equal to 4 and x is equal to 2. Similarly, for b equal to 1, we are getting x plus 3 equal to p to the power b, we know, and p is 5. So that means 5 to the power b. Sorry, 5 to the power b means 1. So from here we are getting x equal to. In both the cases, we are getting x equal to 2, and we know that p equal to 5 here also and p equal to 5 here also. So now we are going to find what will be our n. For that, we are going using that equation 2x plus 1 times x plus 3. So we are replacing the value of x here. We are getting 5 times 5 is equal to 5 square. And also we know that p is 5. So that means by replacing p by 5 is equal to 5 square, which gives us n equal to 2. Similarly, as x equal to 2 and p equal to 5, we are getting also here n equal to 2. So in both the cases, we are getting the solution will be, the solution is x equal to 2, p equal to 5 and n equal to 2. Okay. So I think, so now we are going to case 2. What is our case 2? When GCD of 2x plus 1 comma x plus 3 is equal to 1. So that means they are co-prime. What does that mean? That means p to the power a and p to the power b are co-prime also. So they both the power of p, but they are co-prime. So that means either p to the power a equal to 1 or p to the power b equal to 1. Okay. So what does that mean? So p to the power a equal to 1, a means 2x plus 1 is equal to 1, which gives us x equal to 0. And for that, x plus 3 is equal to 1, for this x equal to minus 2. But we have already told that x should be greater than equals to 0. So that means this will not be our desired solution. So for x equal to 0, what will be the value of p? Okay, we will find this. We are going to use p to the power n is equal to 2x plus 1 in times x plus 3. So we are put replacing x equal to 0. That means 1 times 3 is equal to 3. So now e to the power n is equal to 3. So could you tell me what will be p? P is nothing but 3 and n equal to 1. So therefore our solution is x equal to 0, p the prime number is 3 and n equal to 1. What is the final answer? Final answer is, we have two solutions. One is 2, 5 and 2, and another is that 0, 3, 1. Okay, I hope this video will help you to prepare the Olympiad exam. So thank you. God bless you all.